What we're talking about today is lesson 78, solving quadratic equations, part 2. This should be a very easy lesson for you guys because we have talked about difference of two squares before, and we talk about them in Algebra 2 or in Algebra 1, so that's something that you should already have a good idea on. Okay, it says some quadratic equations can be solved by factoring a difference of two squares and then applying the zero product property, which states that if the product is 0, then at least one of its factors is 0. Okay, so the difference of two squares, the key to that is that you have to have a difference. They have to be being subtracted, and the two things that we're dealing with, they have to be perfect squares. And once they are, then we can set up those two sets of parentheses, take the square root of a that goes in the front of both, then we say plus or minus, and the square root of b goes in the end of both, and that's it. Okay, so for example 1, it wants us to solve the quadratic equation. 9x squared is a perfect square, 25 is a perfect square, and the difference is what's happening, they're being subtracted. So I'm going to split it up, and I'm going to say the square root of 9x squared is 3x, right? Because 3x times 3x gets me 9x squared. I have plus and minus. The square root of 25 is 5. And that's my final answer, except for it wants me to solve it. So I need to set each of these equal to 0, just like we normally would when we factor. Okay, oops, I put plus for both of them. That should be minus. So over here I'm going to subtract 5 from both sides. I get 3x equals negative 5. Divide by 3 on both sides. So I get that x is equal to negative 5/3. Over here I'm going to add 5 to both sides. So I get 3x equals 5. Divide by 3 on both sides. X equals 5/3. So that's my solution. B, we're looking at the same thing here, except for we always want to set it equal to 0. Okay, they have to be on the same side. So I'm going to rewrite the problem because I have a weird box around that for some reason. So I'm going to subtract 63 from both sides, and that'll cancel out. So I have 7x squared minus 63 equals 0. Now I do not have a difference of two squares right now because 7 is not a perfect square and neither is 63. But I can factor something out first. These are both divisible by 7, so if I factor out 7, I'm left with x squared minus 9 is equal to 0. Okay, 7 times the quantity of x squared minus 9. And this, now I do have a difference of two squares. So I can write it as 7, and then I'm going to go ahead and factor that difference of two squares. The square root of x squared is x, plus or minus the square root of 9 is 3. So then to solve this, all I have to do is set each part equal to 0, which we can just look at this and see this one would be x is negative 3, this one will be x is positive 3. Final answer. Okay, so solving a cubic equation with a quadratic factor. So what we're going to do here is basically the same thing we just did. We're going to factor something out of both of these first to start with, and I can factor 10 and x out. So I'm going to take out 10x, which leaves me with x squared minus 1 equals 0. And sometimes this is a type of difference of two squares that confuses people because of this 1. You have to remember that 1 is also a perfect square because 1 times 1 gives us that 1, right? So we are good to go to factor this. So I went ahead and split up my x squared into x times x plus or minus, and then the square root of 1 is 1. So then all I have to do is set each part equal to 0. So I have 10x equals 0, x plus 1 equals 0, and x minus 1 equals 0. Okay, so here x is equal to 0, here x is equal to a negative 1, and here x is equal to a positive 1. That should just be a 1. That's our final answer. On this one, we're doing the same thing. Okay, x to the 4th, another thing that could confuse you, but x to the 4th is also a perfect square because to get x to the 4th, I can take x squared times x squared. Okay, so I'm just going to set up my parentheses here. Set it equal to 0. So the square root of x to the 4th is x squared, I already said. plus or minus, and 16 is going to be 4. Okay, now something you need to recognize is that I have another difference of two squares, and notice this one is not a difference, so that one will not work. So I'm going to just have x squared plus 4, and then I'm going to split this one up again. So the square root of x squared is just x plus or minus. The square root of 4 is 2. Okay, so you have to watch for that because they'll try and trick you. So then you need to set each part of that equal to 0. Okay, so whenever we do this, we have x squared plus 4 is equal to 0, x plus 2 equals 0, and x minus 2 is equal to 0. Subtract 4 from both sides here. It gives me x squared equals negative 4. I don't want x squared though, I just want x, so I have to take the square root. So I have that x is equal to plus or minus, and then whenever I take the square root of that, okay, the square root of 4 is 2, but with that negative, remember we have to include I. So x is plus or minus 2i. Here, x would be just negative 2. Here, x would be 2. Okay, final answer. It says to identify the real roots of this graphically. Okay, we just found all of the roots of it, right? Okay, but it wants us just to find the real roots. And when it says graphically, what do you think we should do? Hopefully you're thinking graph. Okay, so get out your calculator, and I want you to plug in this x to the 4th minus 16 into your y equals. And I don't have my calculator again today, I apologize. So whenever you graph this, it should look something like this, right? So you have this point here and this point here, and this is at negative 2, 0. This point is at 2, 0, which tells us that our two real roots are negative 2 and 2, which you should have been able to tell just by what we did on the last one, because obviously the plus or minus 2i, that's an imaginary root, right? Because it has the I. These are our two real roots. On example 4, it says solving a quadratic equation using perfect squares. Okay, these, what they're wanting you to recognize is that these are perfect square trinomials. Okay, so on the first one, it's where we can take the square root of this first part, which is going to be 3x, and then since it's minus and then plus, it's going to be minus the square root of our last term, which is going to be 2, square it, minus this one, they're all being added, so I'm going to have x plus 5, because I take the square root of both of those, square it, equals 0. So now what I'm going to do is I still have a difference of two squares, because I have a difference and both of these quantities are being squared. So I'm going to have to set up some brackets here. So I'm going to have a lot going on. Okay, and I'm going to take the square root of the first one, which is going to just be 3x minus 2, right? Because if I square root this, the square and the square root will cancel, just leave me with that quantity. So it's going to go in the front of both. And then I'm going to put my plus and my minus. And then I'm going to do the same thing with this one, take the square root of it, which leaves me with x plus 5 and x plus 5. Okay, so now all I need to do is simplify. So over here, this would be 3x minus 2 plus x plus 5. This one I have to distribute that negative, so I have 3x minus 2 minus x minus 5. So I can combine my like terms. So in this first set I get 4x, and then negative 2 plus 5 is going to give me plus 3. Then I have 2x, and negative 2 minus 5 gives me a negative 7. And do they want me to continue with this? Okay, so then this is all equal to 0, which I didn't write that at the other steps. So then all you have to do is solve for your 0, which is going to be 4x plus 3 is equal to 0, and 2x minus 7 is equal to 0. So I can subtract 3 from both sides. I get 4x equals a negative 3. Divide by 4 on both sides. I get x equals negative 3/4. Here I'm going to add 7 to both sides. So I get 2x equals 7. Divide by 2 on both sides. x is equal to 7 over 2. Final answer. Example 5, application of vertical motion. It says the height of a free-falling object, neglecting air resistance, is given by the function h of t is equal to negative 4.9 t squared plus v naught t plus h naught. We just dealt with this same function a couple days ago, where h naught is the initial height in meters, v naught is the initial velocity in meters per second, and ht is the height in meters at time t. How long does it take for an object to hit the ground after it is dropped from a height of 40 meters? Okay, so what we're going to do here is we need to start by rewriting the function that we're working with. We have h of t equals negative 4.9 t squared plus v naught t plus h naught. Okay, and we know it's being dropped from a height of 4 meters, so that's obviously going to go in for our h. Okay, our h naught. So I have negative 4.9 t squared plus, and then it also says, let's see, it wants to know how long it takes for this to happen, for it to hit the ground after it's dropped. So we're talking about once it's hit the ground, that's going to be a velocity of 0. Okay, this is equal to h of t. Okay, so this part, whoops, I didn't mean to put a plus there, that's supposed to be, or an equal. Okay, so this part will cancel out. I have h of t is equal to negative 4.9 t squared plus that 40, right? For me to be able to simplify this, I need to essentially make it into a difference of 2 squares like I have been. Okay, so what we're going to do is first I'm going to divide out negative 1 from both sides, or from both of those. So if I divide by negative 1, I'm going to end up with h of t equals, this will give me positive 4.9 t squared, and then minus 40. Now 4.9 is a perfect square, so is t squared, but 40 is not. A way to make this a perfect square really quickly would be to multiply it by 10. So if I multiply the whole thing by 10, I'm going to have, which I can do to both sides, okay? So I have h of t is equal to 49 t squared minus, not an equal sign, minus 400. Okay, now at this point I can go ahead and factor it. So I have h of t equals, I have a difference of 2 squares, so the square root of 49t squared is 7t. I have no idea why I just wrote a 4. 7t plus and minus, and then the square root of 400 you should know is 20. Okay, so at this point all we have to do is set both sides equal to 0, or both quantities equal to 0. So I have 7t plus 20 equal to 0, and 7t minus 20 equal to 0. So if I subtract 20 from both sides, I get 7t equals negative 20, divide by 7. T is equal to, let's see, they just leave it as negative 20 over 7. Over here, we're going to add 20 to both sides. So I get 7t equals 20, divide by 7. T is equal to 20 over 7. And once again, we can't have a negative time, okay, so this one will not work. So we're talking about t equals 20 over 7, which you could go ahead and divide to find the actual time, which is going to be approximately 2.86 seconds. Okay, and that is it. Your homework for today is lesson 78, A through G, and 5 through 20. You have the rest of the outer work, and you should do so quietly. This will be due when you walk in the room tomorrow and graded as a class. Have a good day.